Good day and welcome everybody. Now with sound on to this webinar where we will be examining the topic of enhancing the early detection of Alzheimer's disease through the use of digital technologies. My name is Kim Barton-Christensen. I am the CEO and co-founder of Brain Plus, a digital therapeutics company that specializes in early detection, treatment, and prevention of Alzheimer's disease and other brain disorders. I'll have the privilege of moderating today's session and introduce a group of esteemed speakers and panelists that are all experts in their fields. They will shed the light on this topic from a number of angles and talk about the challenges and opportunities of early detection of Alzheimer's disease. To me personally, it is really staggering that since 2013, Alzheimer's, or dementia rather, has been the leading cause of death for women in the United Kingdom, and in the developed countries, 1 in 3 older adults are dying with dementia diseases. So early detection of the underlying disease causing the dementia, such as Alzheimer's disease, is one of the important pieces to solving this massive problem. So therefore, I'm really looking forward to hearing the different angles today from our different speakers. We'll be looking at perspectives from the human side, the patient side, people who actually have dementia, from the scientific and the clinical side, and from the technological perspective. We'll be answering questions of why and how do we do early detection, and also talk about some of the more fundamental challenges related to actually being successful in doing early detection. On the program today, we will start with the experts. First, there will be a testimony on today's topic from the viewpoint of a person who is living with dementia, and this is Dr. Helen Rochford-Brennan, the chair of the European Working Group for People with Dementia. Helen, unfortunately, due to illness in the family, cannot be here herself, but her colleague and supporter, Kamal Gagan, will be speaking on her behalf. Next, we'll have Professor Masood Hussain from Oxford University talking about applying digital technologies in detecting cognitive decline. Then, Professor Martin Rosser from NIHR and the UCL Queen Square Institute of Neurology will be talking about the pitfalls and challenges in early detection. As the third speaker, we'll have Eric Salmon from the University of Liège talk about cognitive and neuroimaging challenges associated with preclinical Alzheimer's disease. The final presentation is split in 2 parts. It is about the Alzheimer's Detect and Prevent European project that is about developing specific digital solutions for early detection of Alzheimer's disease. And our presenters here will again be Professor Masood Hussain and Ulrik Dietler-Eriksen, who is the co-founder and chief product officer at Brain Plus. In the second half of the webinar, we will have an open discussion. This is a chance also for the audience to give questions to the speakers. You will give your questions, you can write down your questions in the chat during the presentations. There will not be questions answered during the presentations themselves, but what you do is you will write them in the chat, which is in the right-hand side of your screen. You will be able to see your own questions, but it's a private chat, so you will not be able to see the questions of all the other people writing questions in the chat. Just on a practical note, you can open and close the chat in the upper right-hand corner of the screen. There's this little sign with an arrow pointing to the right. That's to close the chat, and you can reopen it by pressing the chat button. If you want to address a particular attendee or speaker in the chat, you need to write the little @ sign, which is in the lower part, the bottom part of the chat window to the right. So that's all for practicalities and introduction. So without any further ado, we will start with the first speech, which is a speech written by Dr. Helen Rochford-Brennan. And I'll just turn. Just a quick introduction to Helen. Helen is a global dementia ambassador. She's also the chairperson of the European Working Group of People with Dementia and is the group's nominee to the board of Alzheimer Europe, the pan-European patient advocacy organization for Alzheimer's disease. Helen is also on the monitoring committee of Ireland's first national dementia strategy and the WHO focus group. Helen was diagnosed after a 5-year struggle with early onset Alzheimer's 8 years ago at the age of 62, and she has written very personally about the topic of living with the Alzheimer's type dementia. She's an ardent advocate trying to raise awareness of dementia and is actively campaigning, educating, and writing on the topic. In her place today, I would like to welcome Carmel Gagan, who is working and supporting Helen closely as part of their European Working Group of People with Dementia. Carmel, the floor is yours.
Thank you, and good afternoon. And I will speak, I'm going to read out Helen's presentation as she no longer uses slides. So, I have been invited to give the patient perspective on your work. You are interested in me because of my symptoms, my pathologies, the plaque on my brain. Clinicians are interested to learn more about the patient experience. And in research terms, I am interesting because not only do I have Alzheimer's disease, but I can tell you how it feels and impacts on my life. But I want to remind you that I am more than a patient or a collection of symptoms. I am a person, a mother, a wife, an aunt, a friend, a recent dog owner, and I have a full and varied life. Your work requires you to break down people like me into our pathologies, but I ask you to remember the people behind the science. I live in Tubbercurry, County Sligo, a town in the beautiful northwest of Ireland. I live with my husband Sean and my dog Lexi, and our son Martin lives in London. I like to take walks each day, and I love theatre, and I enjoy a glass of wine. I'm grateful for the technology I have in my life. I have lived in Connecticut, Lexington, Chicago, and in London for a number of years. As part of my advocacy work, I travel all over Europe, and meeting other people living with Alzheimer's who are having their voice heard has brought me great joy. Today, we're speaking about enhancing the early detection of Alzheimer's disease through digital technologies. And I want to address two parts. But firstly, let me tell you about my life with Alzheimer's. As I was preparing for today, I was trying to think of an appropriate, inspiring quote, and the words of Neil Armstrong came to mind. Quote, "Research is creating new knowledge," unquote. I am delighted to engage with you all on your new knowledge, which is so important to me as a person with Alzheimer's. Thank you for this opportunity to tell you about my life with Alzheimer's, my advocacy work at home and in Europe, and being acknowledged for my work as an advocate. As a person living with Alzheimer's, being an advocate marked the start of a new journey for me. It marked also the start of a new conversation about Alzheimer's and the struggle to have my rights recognized and upheld. We are all different. So when you see one person with Alzheimer's, you only see that person. In my mid-50s, I started to experience memory problems. And finally, I was diagnosed with early onset Alzheimer's in 2012 at the age of 62, while I was busy working and planning my retirement. It was like a slow realization that a creeping fog had descended on your life and it was there for good. My day-to-day tasks became worryingly challenging. First, it was forgetting words, stopping mid-sentence, wondering what was I about to say, searching, covering up, forgetting again. Simple tasks that I'd been doing all my life became a chore and a worry. I found my slowed thinking very difficult to deal with. It impacted on me in many ways, such as trying to remember something I had read or newly learned, seeing words but being unable to reach them, forgetting events of a recent meeting, forgetting what people had asked me to do. I can still see the look on people's faces and feel the burning silence when the words failed to come to me at a meeting. I began forgetting names, covering up and trying to keep out of the limelight. I was confused and found it so hard to motivate myself to complete tasks. Tasks that once only took mere minutes was taking hours or days. I put it down to taking on too much and just needing a break. Family life became more and more difficult. I would chat to my son on the phone and forget the plans we had just discussed as soon as I hung up, or forget something important my husband had told me. Prior to my diagnosis, I struggled on at work, still hoping that the mental sluggishness was due to stress and overexertion. It took so much effort just to keep up, to maintain the guise of normality. When the opportunity to take early retirement came, I felt I had no choice but to take it. I slowly drifted from the vital, funny, energetic woman I used to be and became inhibited only in the shadows. At home, with no focus outside myself, the days seemed endless. My energy sapped. I slept long hours and lost all motivation. The deepest, darkest grief descended upon me for a life I would never have. I was flooded with lots of different emotions: frustration, loneliness, depression, and anger about life's changes and dreadful isolation. There is no way I can describe the shock of the day I received my diagnosis, or the long, lonely drive home, wondering how was I going to tell my husband and my son. There was, however, also a degree of relief in getting a diagnosis, as I thought I was losing my mind. I remember the conversation with my family, but I remember the conversation with my family, but I do remember the pain. Ask yourself this question: how do you tell your loved ones that within an undisclosed amount of time, you will not be able to recognize them, nor retain any of the wonderful memories that you've banked along the way? I remember lying awake, staring into the darkness, wondering, where do I go from here? In Ireland, there were no supports for anyone diagnosed with Alzheimer-related diseases before their 65th birthday. No support services, nowhere to go, no one to give you advice or tips on how to proceed. Today, younger people find themselves in inappropriate older person services. For me, having spent my adult life campaigning for human rights, this was inconceivable. I couldn't believe that because of a random number, I would be ignored. Worse still, refused all help and services. But I didn't have the strength or the will to fight it. I retreated. I felt helpless for the first time in my life. No plan, no ideas, and no strategies. Those first few months were spent grappling with heartbreak. I felt my career and voluntary work defined who I was and how I was thought of in the community. I was too ashamed to mention my condition to anyone. I was more than aware of the stigma associated with it. I felt there was nobody to turn to except the internet. I wish somebody had been there to hold my hand and explain to me Alzheimer's is not just about memory, that it impacts on our ability to accomplish daily tasks, that it hinders our thinking process, that we can have sensory problems and horrendous pain that agitation brings, not just to me, but to my family. Please believe me, it is not a life sentence, if only someone would have told me that. The problems my family faced were immense. Living with the pain of watching their loved one change, the relationship dynamic change. Our loved ones, our family partners go into carer mode. My husband worried about our intimacy. It seems like we could no longer be a couple, when what we needed was some advice on continuing to do all the things we did every day. I am the same person they loved and cherished, but we forget things. There is a huge issue throughout the world of people living with Alzheimer's being prescribed psychotropic medicines, in particular in our nursing homes. And many of us looking at COVID outcomes feel this is a contributing factor to so many deaths because people cannot express themselves. In fact, here in Ireland, research has found that those drugs have no benefit whatsoever for people living with Alzheimer's. Aside from, as far as I am concerned, putting people to sleep and keeping them quiet. So what if we wander up and down? Many of us were full of boundless energy before our diagnosis. There is no cure for this disease, so all I have is hope. My doctor advised me to get in touch with an Alzheimer group, and eventually I got the courage to seek help. The Alzheimer nurse advised me to tell people I had the illness and get involved in research, which I did through Trinity College Dublin. This led me to the Alzheimer Society of Ireland and the newly formed Irish Alzheimer Working Group. Until I reached out and got help, all I could see was grief. Grief for a life I would never have. Believe me, this is not the life I had planned. But somehow, after I told people, I could see some light. Thankfully, I was able to participate in cognitive rehabilitation research through Trinity College Dublin and the Alzheimer's Society of Ireland. And this gave me some valuable tools and strategies. For example, writing down everything, using a diary, a calendar, whiteboards, iPhone, iPad, computer, and taking part in outdoor pursuits. I chose walking and gardening. I was now adjusting to life with Alzheimer's, which I realized is one of the biggest challenges facing people with the condition. The illness has not gone away, but I have just learned to handle it better. It does not define me. 8 years ago, I would not leave the house. Now I'm traveling with assistance, driving and having an annual driving assessment, and living life with support from family, friends, the Alzheimer's Society of Ireland and Alzheimer Europe. Most importantly, I have hope for living a good life as long as I can. I have accepted my diagnosis, and this has allowed me to go one step further and to start to look for a quality of life as a person with Alzheimer's who is also a mother, a wife, a sister, a community activist, and a citizen. I was the first chair of the Irish Alzheimer Working Group, and now I am chair of the European Working Group of People with Alzheimer's, and privileged to sit on the board of Alzheimer Europe. Initially, the Irish Alzheimer Working Group supported me to get involved in advocacy and policy work. When I was first diagnosed, I did not think about my rights, and yet I was facing many human challenges. All my life, I've been an advocate of human rights and social justice. I find myself now fighting, not just for my rights, but those of all people with Alzheimer's in Ireland and across Europe. Realising our rights is one way of ensuring that we turn the challenges we face into an opportunity. We need a culture where people with Alzheimer's have a voice, where they are included in driving forward action on the illness. Stigma is still a major problem across Europe. We can eliminate stigma by involving people with Alzheimer's in decision-making and strategy. I can't stress enough how important it is to have people with Alzheimer's involved in decision-making. Public patient involvement is important, as we are the experts. We have the illness. I think my advocacy has finally helped others to speak up and have their voices heard. And I have already learned that person-centered Alzheimer care has been found to have significant benefits for the person with Alzheimer's, our carers and extended family. It gives a better quality of life, and it delivers on our rights as not only people with Alzheimer's, but as European citizens. Knowing our rights is empowering and encouraging. When we speak, we also speak for those who have no voice, but whose human rights matter just as much as yours. No, not everyone can become a public advocate like I am for people with Alzheimer's, because it's a difficult task. It takes almost total dedication and shedding lots of tears along the way. I see the death and misery that Alzheimer causes, but I put my emotions to one side and I tell my story, because the rewards are huge, not just for me, but for the millions of people living with Alzheimer's around the world. As an advocate, I hope to create a better quality of life that someday everyone will benefit from. It is important to note that today you are meeting professional Helen. Helen, who is a campaigner and a public speaker. It is easy to forget that public professional Helen has Alzheimer's. And it is also easy to dismiss me and my fellow advocates as unusual, remarkable, and anonymous, and many other words. But to me, to be public Helen, private Helen has to struggle with the reality of Alzheimer every day. I burn my hand cooking. I light the fire with a dishwasher tablet. I make soda bread without the soda, the curry without the curry powder. Recently, I got water in the vacuum cleaner and left it by the fire to dry out, and it melted. And now my ability to write is diminishing. But I keep going to ensure that care paths are improved, that rights are upheld, and that the condition is understood. My social health is one of the most important things in my life, because not only does it impact on my life, it also impacts on my family and my loved ones. With support, I have the capacity to maintain my personhood. I am still pretty resilient in the face of adversity. Right now, I try to care for my husband who has a chronic illness. We get no support from our health service. I can also exercise my choices in life. I want people to look at my abilities and not my disability. I can speak out against stigma, and I can participate in community projects. Each day when I get up, I have to make choices on how to manage my day. This is not easy because I forget and sometimes have to replan. It is important I still sort out problems and household chores, pay the bills, etc. I need to be able to cope with many different issues Alzheimer's present. Maybe it's emotional, but I must work at adapting to the situation. Prior to my diagnosis, I was a social butterfly and believed in the quote, "When you can't find the sunshine, be the sunshine," unquote. Even though my life has irreversibly changed, those days are gone. However, my Alzheimer life has given me wonderful experiences, and I hope I bring sunshine to its darkness. I still love being socially active. This can come through my advocacy work, my community work, meeting old friends, having family get-togethers, shopping, hiking, the theatre, a musical event, and my spirituality plays an important role in my well-being. I believe my social world is very meaningful to me, as do my doctors. I truly believe it's keeping my brain healthy for me, and eventually, and equally important, it's keeping anxiety about my future minimal. I advocate for a focus on social health, for doctors to measure my social engagement and my empowerment, not just my blood pressure. We need a broader, more inclusive view of health. I speak to universities, hospitals, pharma, councils, healthcare professionals, and policymakers, and many organizations here at home and across Europe about my journey with Alzheimer's. Because I believe education is key to removing the stigma and fully integrating people with Alzheimer's into our communities. What I have spoken about are not new, nor are they extravagant. They're basic rights. They include the right to information, the right to a timely diagnosis, the right to services and support, and a range of other basic rights that you or I living without Alzheimer's may take for granted. Firstly, I want to speak about ethics of that early detection. I very much welcome this innovation and see the value of early detection. It will identify risk factors, help learn about the progression of the disease, and in particular, the science of Alzheimer's. But I want to consider the language and the ethics around telling a person that they are pre-Alzheimer's or at a risk of developing Alzheimer's. Firstly, what exactly does that mean? I'm sure the researcher understands, but the research subject, the person? I work daily to challenge stigma around Alzheimer's. I observe fear and a lack of understanding. You must consider this fear and stigma as you deliver the news to the participants in your study. Someone who is identified as being high risk in your study may attend their GP, but they may not have any symptoms. What can their general practitioner do for them? Does the general practitioner have a full understanding? All of us here today have heard of tangle tie, the immune system, blood deficiency, and of course biomarkers. But we all know there is no 100% diagnosis. I would ask what supports are available for a person whom research concludes is at very high risk of developing Alzheimer's. In a way, you are forcing a person to confront diagnosis, but there is not an Alzheimer diagnosis, only the possibility of one. When Alzheimer's disease came into my life, you can imagine the devastation I felt, as I said earlier, as a wife and a mother. How was I going to tell my husband and son in an undisclosed amount of time I may not recognise them or remember the memories we banked along the way? Our affection and love for each other has kept us together, and I felt this was being destroyed by Alzheimer's. Those emotions are likely to be present among people you identify as at risk of developing Alzheimer's. What are your plans to destroy them? What are your plans to support them during disclosure? I look at my experience and realize the supports that I needed. The people for whom you outline potential risks need those supports too. No matter how the news is broken, it is devastating because your life will never be the same. Research should be a reciprocal relationship. Participants in your research must be supported and looked after and not simply viewed as subjects. The second thing I want to speak about is hope. As all of you give me hope, this diagnosis is terminal and it is hopeless diagnosis to receive. Knowing that this work may lead to someone being diagnosed early, allowing them to put strategies in place, makes me hopeful. Knowing too that this work might prevent someone developing Alzheimer's by being aware of the risks and taking steps to mitigate them makes me incredibly hopeful. Being aware of risk reduction is also empowering. Sharing scientific strategies to lessen the risk of developing Alzheimer's is positive. Daily I am greeted with tabloid solutions for my Alzheimer's. Eat coconuts and drink more champagne. Though Sean has cut that one out. Believe quality, extensive data is necessary around risk reduction to stop this confusion. But be careful, living with Alzheimer's is not easy. Some of my colleagues find it difficult to listen to prevention rhetoric. It can create a sense that I could have prevented my Alzheimer's, and we know this is not always the case. Risk reduction campaigns can make a person living with Alzheimer's feel guilty or shame. You must deliver your learnings in a manner that fosters hope and not guilt. I am passionate about research, and at a European level, in my role as chair of the European Working Group of People with Alzheimer's, I am involved in a lot of research from pharma to academics to scientists. I volunteer many hours to this because I hope someday soon we will have a cure and nobody will have to go through what I had to, and Alzheimer's will no longer be looked at as an old person's illness. Alzheimer Europe is working hard to make Alzheimer research a European priority. I want quality, ethical research. I want a model that has sustainable funding and one that is transparent. And most importantly, from the patient perspective, I want co-design and shared power. When I was preparing for today, I read a quote by a scientist, Sean Strobes. He said, quote, "Ethics and oversight are what you eliminate when you want power," unquote. With that in mind, I say that all your research begin from a place of human rights where the person living with Alzheimer's is truly valued. I urge you to adopt the panel principles of human rights approach: participation, accountability, non-discrimination and equality, empowerment and legality. Accountability is of particular importance. Too often people with Alzheimer's are involved in research, but not oversight or accountability. We must be involved at every level. This involvement must involve real power and influence. Nelson Mandela once said, "To deny people their human rights is to challenge their very humanity." People like me with Alzheimer's are finally learning to speak out, speak up, and have their voices heard. When we speak, we also speak for those who cannot stand here, for those who cannot be part of research. but whose human rights matter just as much as mine. Be sure you value and respect our voice. For me, it is important to be at the heart of the fight for change. I need to influence change in a way we talk about Alzheimer's and how we develop Alzheimer inclusive societies. By being here with you on this webinar today, you are beginning that inclusion. Please talk about it. In closing, again, I thank you and one day look forward to seeing your vision come to fruition. Martin Luther King once said, "If I cannot do great things, I can do small things in a great way." I hope the small things I do in my advocacy research work is changing how the world views Alzheimer's. So on behalf of Helen, I'd like to thank you for listening. And just a final note, Helen wants me to once again stress how early detection would have made such a difference in her life, and also would like more emphasis on the health, lifestyle, and social health of those at the point of diagnosis. Thank you.
Thank you so much, Carmel, and please relay our thanks, our deep thanks to Helen for making this speech and giving us an insight into what it is like having received the diagnosis of the disease, living with the disease, and also the positive message that it is not the end of the life, but there's actually a lot that people can do and life really goes on, but also the importance and the necessity of finding alternatives to medicines today and getting the earlier detection to be able to intervene earlier. So thanks so much for sharing this perspective.
Thank you.
We're now around 80 attendees on the webinar, and I'm very pleased now to proceed with Professor Masoud Hussain. He will be speaking about applying digital technologies in detecting cognitive decline. A bit of background on Masoud: he is a professor of neurology of cognitive neuroscience at the University of Oxford and a Wellcome Trust Principal Research Fellow. He also leads the neurological conditions theme of the Oxford Biomedical Research Centre and is a professorial fellow at the New College of Oxford. Masoud is co-chair of the European Academy of Neurology's Scientific Panel on Higher Cortical Functions and is editor-elect of the journal Brain. His research focuses on the mechanisms underlying memory and motivation deficits in patients with neurodegenerative disorders, including Alzheimer's disease. Masoud, you're very welcome. The floor is now yours.
Okay, thank you very much. And yeah, that was also very moving to hear Helen's testimony on this. So I hope that the information we're going to discuss today will be of interest to patients as well as to scientists. So let me see if I can share my screen. I hope you can see that, Kim. Can you see that, Kim?
Yes, we can see that.
Okay, good. I'll start now. So I was asked to give an introduction to digital technologies and how they might be useful to detect cognitive decline. And I think it might be worth just stepping back a minute and think about why use digital technologies at all. And perhaps one thing we could start off with is thinking about the issue of whether they might be useful for large-scale screening for dementia. As Helen had alluded to in her testimony, she was diagnosed relatively late, and I think that's not an uncommon feature of many patients, especially with younger onset dementia, that it takes a while before they become diagnosed. And at the other end of the increasing aging population, there are more and more people who have dementia. And so there might be an important issue about whether we can screen for dementia, but of course there are ethical considerations about doing so, which we might discuss later. Another reason, apart from screening, is whether we might be able to detect the very early manifestations of dementia before even perhaps a clinical diagnosis would normally be made, in order to alter the trajectory, the decline that might otherwise occur. And of course, again, that raises ethical issues, particularly when, as currently, we don't have those disease-modifying therapies. Moving on, perhaps an important issue to consider is whether digital technologies might actually provide us with something which is more sensitive than current methods of screening. So in clinical practice, normally, there are relatively short screening methods to test cognitive function. And of course, people vary depending upon their backgrounds, their education, their cognitive reserve. And so some of those methods are actually insensitive to changes that have occurred in people who are actually functioning at a high level. So digital technologies might provide a means of testing more sensitively than current screening methods. And the other thing that they might provide is the ability to make those assessments occur remotely, particularly in people who, for various reasons, might not actually be able to attend a specialist center or a hospital. And of course, that's become very apparent to us during the coronavirus outbreak. But of course, that's a reality for many patients in different parts of the world, particularly in remote parts of the world, where they wouldn't necessarily be able to have an expert consultation. Two other issues that are interesting, I think, is the ability to monitor progress and the ability to monitor progress when people are not in the clinic. So even if someone has a diagnosis, it's often the case that they may not see a clinician or have an assessment made for 6 months, a year, whatever. And digital technologies, because of the scale at which they can be provided, provide a means of actually monitoring progress more frequently. And of course, again, that raises issues about feedback to individuals, whether that is a positive or negative thing. In terms of clinical trials, they also provide the potential for novel designs of clinical trials. The gold standard in current practice is the randomized controlled trial, but as many of us know, those types of design have their problems, and one of which is the fact that no one patient is the same. As a clinician, what we're really interested in is whether drug A actually has an impact on our patient. And perhaps one way forward is to think about novel trial designs at one extreme of trial designs of N of 1, where you're actually looking within an individual to see if you can make an impact. Now that is not practicable under current formulations in terms of the way we run randomized clinical trials. But if you had many frequent measurements within an individual at baseline, during an intervention, or during placebo, you now have the potential to see whether there's a significant change within an individual because you have the power to do so, statistical power to do so. And digital technologies potentially provide that power at a remote way of assessing people's cognitions. And finally, and this is something to perhaps think about for the future, is whether that platform which allows you to assess people's cognition also might have an impact in terms of improving cognition, whether cognitive training could ever have the impact in terms of altering the trajectory of dementia. So I think these are some of the issues that are important when considering why we might use digital technologies. To give you an example of digital assessment at scale, I thought I'd bring up this app, C Hero Quest, which I'm sure many of you have heard of. It's designed by my colleagues Michael Hornberger at the University of East Anglia and colleagues at UCL. And what they've done is essentially partnered up with Deutsche Telekom to provide a gamified way of assessing people's navigation ability. In this kind of situation, it's a game where you have to visit certain locations in order to recover memories. And if I can just get the laser pointer going. So you might be shown a map like this. This is your starting point. You have to visit these locations 1, 2, 3, and 4 in turn before navigating home. And you can see here from 1,000 trajectories of people who've used this task that although these locations are indeed visited by people without the map in place when they're navigating in this kind of environment, of course, sometimes people do get lost and they go into inlets and places that they shouldn't have. And this gives an idea of their navigation skills, their wayfinding. And these researchers have also looked at people's abilities to do what's called path integration. From this location, what is the direction back to the home starting point? These types of simple measures can be quantified in sort of a global score. And this is performance against age from 20 all the way up to beyond 90. And over 2 million people were tested worldwide. It's a remarkable achievement, but it just gives you the idea of what can be done with digital technology at scale. And I thought I might mention a couple of things here. One is that you can see that decline in performance starts all the way from 20 down to 70 here. And the other interesting finding was that on this kind of task, on this kind of navigation task, overall, on a global scale, there was certainly a significant difference between the sexes, with males performing better than females on this task. And the other interesting feature of this was that actually, and this is part of the problems that might arise, above the age of about 75, you can see that performance seemed to significantly improve. But the variance here is quite high, and that's really a reflection of the fact that the people who were engaged on this task above the age of 75 might well have been very high performers and not necessarily representative of the general population. So then that's something else to bear in mind in these kinds of digital platform assessments. The other way that people have gone is to think about whether wearables, devices that you wear on your body and are monitoring performance, that could be simply from the point of view of your level of activity right through to your heart rate. Wearables, whether they might be able to give some insights to people who are at risk of developing dementia. And one extreme, this is the sort of digital home devised by my colleagues at Imperial College London, who are part of the UK Dementia Research Institute, thinking of means by which to monitor people in their homes. And that could be levels of activity, sleep, but also in terms of temperature, for example, to see if they're developing an infection, whether they're taking medication correctly, and whether actually there's been a change in some way in terms of their normal pattern of activity. And this is done with various devices and measuring devices within the home to put data in a data box at home and in an anonymous way allow that data to be processed through machine learning or AI methods remotely in the cloud. This is very new and an interesting way to move forward, not only for perhaps early detection, but also in people who've already had a diagnosis. And the third way that one can look at digital technology is really in terms of actively testing cognitive function. There are several types of platform out there, and today we're going to talk a little bit about the platform that was developed with Brain Plus, which is a company based in Copenhagen and our partner in terms of trying to develop this app through EU funding. And I'll show you a little bit of that later on. So perhaps it might be worth just raising a few issues about detecting dementia early. I think many people would agree that it's likely to be important if there are disease-modifying treatments that are going to be effective. you'll be very well aware that a lot of money has been spent in potentially disease-modifying treatments which have not been found to be effective. And one possible reason for that might be that they were tested too late. In people who have an established clinical diagnosis, the pathology may have been there for 10 years or more, and so the potential of trying to change that trajectory at that stage might be far more limited. Regardless of what's out there in terms of treatment now or in the future, it is probably an important thing to allow people, if possible, to make life choices at a time when it's possible for them to do so. So one important reason, I think, for detecting dementia early is to allow people to make those choices and plan for their lives at an early stage. But we have to bear in mind that as yet, there is absolutely no convincing evidence, in my view, that digital technologies can detect dementia early. And it may prove to be the case that they can, but we don't have any convincing evidence that they're able to do that at the moment. And as I think most clinicians will tell you, dementia remains a clinical diagnosis. And I think we heard in Helen's testimony that even Alzheimer's disease diagnosis is a probability type of exercise. We're making a best guess at the underlying pathology. So although many of these technologies might be important in screening, in filtering, in finding people who seem to be moving off the normal trajectory, a clinical assessment would still be necessary to make a clinical diagnosis. And perhaps some of that is brought to the fore by thinking of a couple of groups of people. One of those is people with mild cognitive impairment, MCI. Now, these people are at high risk of developing dementia of the order of 10% per year. But it's important to remember that some of those patients who are given a diagnosis of MCI actually improve. They move out of that category into normality. So there are people who appear to have mild cognitive impairment, but don't necessarily have preclinical dementia. And we need to be careful about what sort of information we feed back to those individuals if we're doing digital remote assessment. Similarly, many of us are very well aware of people who have subjective cognitive impairment, SCI, or subjective cognitive decline. These are individuals who feel that their memory is not as good or their cognitive function is not as good, but in whom at least the methods used in a clinical screen or even more deeper neuropsychological assessment doesn't necessarily reveal any abnormality. Now, would sensitive digital technologies actually show that they are impaired in some way, even though these individuals might not have dementia, and most of them are very unlikely to develop it? So this really raises the other side of the coin. It's all very well to be able to detect dementia early, but it's also important to realize that a negative outcome from this is that we might be increasing people's anxiety in a detrimental way, particularly in individuals who don't have preclinical dementia. The final area I thought we might just briefly discuss is the advantages and disadvantages of remote assessment. So it's great if someone can actually understand the task they have to perform, if they can do it. But that isn't always going to be possible in a remote setting when you don't have a clinician or a neuropsychologist sitting next to the person explaining what they have to do. So we have to bear that in mind. As I said previously, it's perhaps empowering to allow people to be able to access this kind of service that they might not be able to travel to in a normal circumstance, and also to be able to monitor their progression between clinic visits. I might see a patient once in 4 months, once in 6 months, but I don't know a lot about what's happened to them in between, apart from what they tell me or a family member tells me. This might be a way of getting objective information between those visits. And in terms of clinical trials, well, this assessment, this form of assessment, as I said, provides a new way to think about measuring the outcomes of clinical trials. Our current methods, I think most people would agree, are rather clunky and may not be very sensitive in detecting the kinds of changes we're interested in. So let me end here by just summarizing. So there are emerging technologies which provide digital platforms and may allow us to detect cognitive decline early. They've got lots of potential positive outcomes for screening, for earlier diagnosis, for remote monitoring, and as I've alluded to, potentially for even improving clinical trial measures. But we have to understand that we're at a really very early stage and yet to show definitive results, yet to show that these things really would make a difference. And as I've alluded to, there are also some potential negative outcomes, for example, of feeding back scores from such technologies to people who are actually well, or using only these readouts to inform a clinical diagnosis. So I'll stop there. Thank you.
Thanks so much, Mr. And that gave a great overview of some of the possible uses of digital technologies and also some of the challenges that I'm sure we will get back to in the open discussions. So thanks a lot for that. Great. Now I would like to welcome Martin, Professor Martin Rosser. He is the NIHR National Director for Dementia Research and Principal Research Associate at the UCL Queen Square Institute of Neurology. Welcome, Martin. I'll just give a brief background for you here. Martin is trained in neurology at the National Hospital of Queen Square and undertook research into neurochemistry of degenerative dementia in the MRC Neurochemical Pharmacology Unit at Cambridge. He's also a professor of clinical neurology at the National Hospital for Neurology and Neurosurgery. He established a clinic for cognitive disorders, which acts as a tertiary referral service for young onset and rare dementias. Clinical research interests of Martin include degenerative dementias, in particular familial disease. He has also been the editor of the Journal of Neurology and Neurosurgery and Psychiatry and the president of the Association of British Neurologists. Martin, very warm welcome. The floor is now yours.
Thank you very much. I hope I have the microphone turned on. I don't have any slides. My task is to consider some of the problems and pitfalls here, so that I don't appear to be the pessimist. I think this is a very exciting area, and so my comments, I think, would allow me to think ahead a little bit about how one might use the information and some thoughts about the conceptual basis. I think we do have a problem when we talk about diagnosing Alzheimer's disease. It's relatively easy if we think of familial Alzheimer's disease, where we have a clearly defined genetic mutation, a cascade of molecular pathologies, and an emerging functional impairment. But that's very rare. Most Alzheimer's disease occurs in the elderly. It's very mixed. We are finding more and more misfolded proteins in the elderly age group. And that, I think, makes a diagnosis more difficult. And in a sense, and I think an important sense, the names we give diseases are only names. So people are unwell, they have disorders, they have an impairment of function, but we find it useful to group people and give a name if it helps us either to treat or to prognosticate. Giving prognosis is always very, very difficult. Trying to look into the future rarely works particularly effectively. But I think that's why some diseases come and go, because our understanding changes and they no longer become particularly useful. And I think there's a real problem with dementia. it's useful politically. It's not now very useful clinically. It used to be. I think there was a major value 50, 60, 70 years ago to try and identify those individuals who had multiple domains of cognitive impairment, because it led you to think that these are people who either had a degenerative process like Alzheimer's disease or multiple strokes, as opposed to a focal lesion, a tumor, where you might want to go in and operate. The world is very different now, of course, as we have so many different techniques available to us. But while the value of dementia has gone down, I think clinically, its political value has gone up. So I think I think we're going to have it for some time yet. But there is another problem in the sense that I think a lot of people, a lot of the public, a lot of journalists, many politicians conflate Alzheimer's disease with dementia. And I do as well. I think I often switch between using the term dementia and Alzheimer's disease because I'm using shorthand. And it means I often make category errors because these are very different categories. Alzheimer's disease involves concepts around molecular changes. Dementia is a statement about function. And so when I say things like I'm identifying dementia early, sometimes I'm talking about shortening the diagnostic pathway because somebody has a very real problem, but people are ignoring them. And we know that often is the case with younger people where it's not expected that they're going to have something like Alzheimer's disease. But quite often what I'm really saying is, in my early detection of dementia, is I think I want to, or that I can, identify somebody who has a disease process going on, like Alzheimer's disease, with deposition of amyloid, tau, TDP43, that in the due course of time will give rise to sufficiently severe functional cognitive impairment that they fulfill the criteria of dementia. And that is a category error. And I think we do need to be very wary about how we use these terms and make sure that when we do have a wealth of data that can come from technology and remote assessment, that we are using them correctly. We have the opportunity, I think, with this to predict what an underlying pathology might be because of the pattern of the domains of cognitive impairment. But we will need to confirm that with the appropriate category investigation. So it may well be that we can see a prominent amnestic deficit that implies that my longer-term episodic memory is impaired. There's a high chance that I'll have an amyloidopathy underlying this that I may or may not have a treatment for, but to do that I'll need a molecular marker of amyloid. So it'll help as a screening for the next stage of investigation. The problem about identifying those who are at high risk of progression is, of course, a very different area, and Helen's talk spoke to that. Masood has, highlighted that as a risk around anxiety, etc. But there's also, I think, an area for caution. It's reasonable to think that if you go in early, you will have a better outcome. And we tend to look to oncology to support that argument. And it sounds very reasonable. Well, why wait for a cancer to metastasize? That's very similar to saying, well, we'll wait until somebody's got a dementia, i.e. severely impaired, before we diagnose Alzheimer's disease. But oncology is very different. We have much more sophisticated means of identifying what's a benign tumor, what is a malignant tumor, and how they may progress in a way that we just do not have in the neurodegenerative diseases. And even in oncology, depending upon your genotype and your age, whether to intervene with prostate cancer is not necessarily a good thing. And so it depends upon the nature of your intervention. And for many people, it may be that living with an amyloid load may be better than intervention in the way that living with a prostate cancer is better than an intervention or prostatectomy. So these are just finished there. These are comments that are quite general about what our concepts are around what we mean by diagnosis, and they're not to be pessimistic, because I think it's a very exciting area, but that we do need to be careful about the words we use and how we're going to apply these data. I do think for me, and this is just personally, one of the most important potential uses is the one that Masood alluded to, which is the trial of n=1. That's what clinicians do. They're always doing trials of n=1. They're just methodologically don't seem to be very sound, but that's how clinicians practice. And I think this really will provide an excellent way of treating people. So I will stop there. Thank you.
Martin, for bringing up giving us some perspective on some of the overall challenges related to early detection, but I'm happy that you also are excited about this area. And I think some of these challenges can also give perspective to all of those of us who are working with this field in terms of thinking about how we can address some of these larger challenges, how perhaps digital technologies can help distinguish in the future and help the clinicians in their work. So we'll get back to that during the Q&A session. Great. Now I'm happy to introduce Professor Erik Selman. He will be speaking about cognitive and neuroimaging challenges associated with preclinical Alzheimer's disease. Erik is a professor of neuroimaging of memory and cognitive readaptation, and he is the medical director of the Giga Cyclotron Research Center at the University of Liège. He's also responsible for the memory clinic and the service of neurology at CHU Liège. His research is in the domains of behavioral neurology, dementia, Alzheimer's, neuroimaging, and cognitive rehabilitation, and he is the author of over 260 publications and has received more than 10 awards and honors. Erik, a very warm welcome. The floor is now yours.
Thank you. I first wish you to take all preceding points of consciousness into account. When I will make that kind of presentation in quick challenges. First one is the kind of current model we've got for Alzheimer's disease, where you've got in the horizontal axis the different stages, and the preclinical is one we are speaking about, but the prodromal is just the few first cognitive memory or non-memory difficulties you get before you are into the so-called dementia stage. And so we think for the time being that amyloid might be first to come and be a risk factor. Then tau in blue might be the second one to come. Neurodegeneration could be there, and cognition, as per definition, would be there only in a prodromal phase. Well, we know that we can, with positron emission tomography, for example, if we've got some pictures, see that compared to the lower pictures where no brain amyloid is there, there are some people with Alzheimer's disease will have effectively a high load of Alzheimer, but we know also this is just a risk factor, because some of those people will not have a dementia, and so that will just be Alzheimer's pathology. But the point is that this kind of information has been used to select people that would enter into clinical trials. And since that's just a risk factor, that has been part of the ethic difficulty, just to rely on one marker. So we know as well in the preclinical stage, and this is a case of people with family history but absolutely no symptom, we can also see some glucose metabolism decrease in some areas that we know are important for Alzheimer's disease. And again, we don't know if those kind of differences from so-called normal population are important from a clinical viewpoint. So one of the new possibilities is to use tracers that will...
Just want to test whether you want to have your presentation on now or if you're just giving an introduction.
No, that's a presentation. Do you see that?
No, we do not yet.
Oh, sorry. What should I do for...
You press the sharing options at the middle bottom of the screen.
Okay. Is that shared?
Not yet. Here we go. Now you just have to put the presentation into full screen and presentation mode, and then we should be there. Great. Now we can see it. Maybe you just want to quickly show the first slide again, and then.
Okay, so this is just the evolution that we can see from the preclinical to prodromal and dementia stage with the amyloid, tau, neurodegeneration, and cognition. And my point was to show that effectively we've got biomarkers such that PET amyloid with kind of normal image pictures and their accumulation in the brain of patients. So with that in mind, this kind of biomarker has been used to select people for clinical trials, but as I said, that's a challenge and an ethical consideration because that's only a risk factor. And we know as well that FDG can be seen in preclinical AD. And my point was to show the new kind of biomarkers which are dealing with synaptic vesicle 2A. So the synaptic vesicles are just in the synapse, the connections between the neurons, and now it's possible to look and measure the density you can obtain in patients with positron emission tomography, and the mild ID on the screen just shows the decrease of synaptic activity that you can obtain here in the medial temporal lobe. So the point here is that we can search for very early synaptopathy, which, and that's the important, could be more directly related to the cognitive difficulties, so that we could have a better selection of people who could benefit from some kind of new treatment. The other point is that clearly treatment for that synaptopathy might be of importance. And if we can demonstrate plasticity, it would be possible to demonstrate again the interest of early intervention. Going back to that kind of model and curve, we see that cognition is coming relatively far. But we know that's not exactly true. And this is already an old story. People had been followed up for many years in Bordeaux, And after 12 years, they were either diagnosed with dementia or not. And then the researcher came back to the initial evaluation, showing that indeed there was something different already 12 years before the diagnosis. And so it was already possible to see subtle cognitive difficulties in those people. So effectively, that might be interesting to make kind of precision of the kind of difficulties. And this is an example we've been looking for familiarity. So the feeling you've got that you've seen that picture already. So on the left, you've got pictures that you will be asked to memorize. And a first classical condition is to mix the picture with others, and you need to tell which one was seen before. A slightly more difficult one is to discriminate between the two different cats, and you need to know exactly which one was a first picture. And what we called entity is now the possibility to not only see a picture in a canonical view, but also see it from other viewpoints, and showing if you are able to see that. And we've seen effectively that this kind of condition may be much more difficult for prodromal people with prodromal Alzheimer's disease. We looked for relationship with part of the hippocampus and the hippocampal structures, and that was correlated with some specific part of the cortex. So effectively, we might have kind of a cognitive biomarker for Alzheimer's disease. And the last point of interest is to look for lifestyle. And now this is in a normal cohort, people with normal late midlife. We've been using what is called a preclinical Alzheimer cognitive composite, so different cognitive measures. And we've been looking for cognitive reserve, where we've got a kind of a physical activities, leisure activities. And here you can see there is a clear relationship between the kind of performance you've got in a composite score and this kind of reserve. So there is effectively a link, and moreover, there is a link as well with some other variables, such as lipid metabolism, such as your sympathetic functioning. If sympathetic functioning is too high, your performance might be low. And that has been quite important to designing possibilities of a multi-domain intervention. And so my final slide is just to show you what has been done by our colleagues in Finland, where they could effectively have a real study and a control study demonstrating that their multi-domain intervention effectively had an interest in order to decrease or lower the decrease of cognition over time. So yes, we probably can make something on lifestyle factors. And I will stop here with the presentation.
Very, very interesting, and beginning to also show some of the different roles that different biomarkers can play in the early detection, and we'll get back to that in the open discussions. Now, as the final two presentations, they're part of one overall presentation of a European project that is aiming to create digital solutions for early detection and risk reduction of Alzheimer's disease called the Alzheimer's Detect and Prevent Project. We'll have again first Masoud presenting, and then after Masoud we'll have Ulrik Ditlev Eriksen that I'll just give a brief introduction to. Ulrik, he is the Chief Product Officer at BrainPlus. He is an entrepreneur in the field of cognitive training and rehabilitation with 20 years of experience in building technology companies from the ground up. His specialty is analyzing the user needs and the customer needs, and doing user-driven concept development and product specifications so we know that the products can do what the users really need, and also bringing these technologies successfully into the hands of the patients or the users. Ulrik has worked with more than 20 high-tech companies within biotech, medtech, and information technology. He has a master's from Copenhagen Business School in Innovation and Business Administration and a minor in psychology from the University of Copenhagen. But I will first give the floor to Masoud, who will give some presentation about the work being done in the ADDP project. Welcome again, Masoud.
Okay, thanks, Kim. So we thought this might be an opportunity to share with you some of the work we've been doing in partnership with Brain Plus. And as I said, this is funded by the European Commission. It's a Horizon 2020 grant. The work I'm going to show you has depended a lot on my cognitive neurology group at Oxford, and I should mention in particular the heroic efforts of Yunus Tabi, who even during the lockdown has managed to collect a lot of data, Raquel Mayo and Sofia Toniolo, who've been very important in this. Emily Butcher has been behind the scenes doing our administration. So I wanted to begin, first of all, by talking a little bit about what has led to the app that we're trying to develop. And it goes back over a decade, really, to work that we started to do in terms of thinking about how we might measure short-term memory. Whether it's long or short-term memory, most people measure memory in terms of how many things you can remember. If I give you a list of items or numbers or whatever it is, it's how many things you remember before you fall off, before you can no longer do well on that task. So quantity has really dominated people's thinking about how to measure memory. But what we tried to focus on is something slightly different, which is the quality of memory. And if you're interested, these are reviewed in these papers. But essentially what we're thinking about is moving from measuring how many things people can recall to trying to measure the quality of memories. And so what we think we can do with that is that we can provide a way to improve sensitivity in the way we quantify errors. And we don't necessarily measure recall in terms of these binary outcomes. Did you get it correct or incorrect? But rather look at the quality of your memory. Because even if you apparently forgot something, that doesn't mean that it was lost in the brain or the brain never encoded that information. And what we want to do is to get a probe, a handle on the quality of information, regardless of whether it would be good enough for you to remember an item or not. So how did we do that? Well, there are many ways you can do that, but one that we found very useful using tasks that go something like this. So in this task, you might see a screen of 1 or 3 items. I'm showing you 3 items here. And here we're using fractals, which are harder to verbalize and therefore a little bit more useful for the kind of task I want to show you. So we show you 1 or 3 of these fractals. There is a short delay of either 1 or 4 seconds. So it's a very short delay. And after that, one of the items that had appeared in the original memory array comes back. And it's accompanied by a distractor or foil. And your task is to identify the item which had appeared originally 1 or 4 seconds ago. And then once you've touched it, to drag it to its remembered location. So first of all, we get a traditional type of metric, identification performance. This is, did you get it correct or not? So this is very much a traditional measure. But in this second measure, we get localization performance. And that gives us a continuous metric of your error. It's not, did you get it right or not, but how well did you remember the location of that item? So it gives us much more dynamic range in terms of the error we get. So in this cartoon here, you can see that I managed to drag the item back to its remembered location, but I might have put it somewhere else. And then you can see I can measure the error between the true location, where it had originally appeared, and the location to where I dragged it. So this gives me a different type of measure to the traditional memory measure. I no longer depend simply on did you remember it or not. I'm also probing the quality of your memory, in this case for location, but there are also other methods which don't have to depend on location, could depend on orientation or color or other qualities in the memory display. Now, just to give you an idea of how this worked, in our original studies, these were all performed on a large computer screen. And here's one of our students performing that task. Oops, let me just get rid of this. So let's just go back here. I hope you can see this. So she's looking at the screen, an item appears. A probe, it appears, with a distractor. She touches the right item and moves it roughly to the right location. Now 3 items. She touches the right item. I hope you got that right. And she moves it again, pretty much to the right location. I want you to look very carefully at the next trial. Oops, not getting that. The next trial. Here there are 3 items. She chooses the right item, but notice what she does. She moves it to the location of one of the other items that was in the memory display. And we call this a misbinding error. So just so that you can understand what that was, I'm just going to drag this back to what she saw. So here are the 3 items. And as you can see, she touches the right item, but she moves it to the location of one of the other items. So it wasn't a random movement. She moved it to one of the locations of one of the other items in the memory array. She misbound the identity of the object and its location. So she got the right object, but took it to the wrong location. Now, using that kind of task, what we've done over the last few years is to look at patients with different types of underlying pathology, which nevertheless target the hippocampus. So in our first studies, we looked at patients with this form of limbic encephalitis, an acquired onset inflammation of the medial temporal lobe and hippocampal structures. And you can see here the swelling of the hippocampus in this case. And we found that those patients could remember the identities of these items. They did well in terms of identity recollection, but they had increased errors when they dragged the item to its remembered location. And all that increase in localization error was attributed to increased misbinding, moving the item to the remembered location of one of the other items. So in this case, instead of moving the item to its correct location, I might move it to the remembered location of one of the other items. And similarly, in patients who've had temporal lobectomy for intractable seizures, and therefore their hippocampus ablated, or actually in patients with familial Alzheimer's disease, as Martin was mentioning, patients who have a genetic mutation, which means that they will get Alzheimer's disease in the future. We found that even in the pre-symptomatic phase, before they had developed dementia or before they developed cognitive deficits which were measurable using standard cognitive measures, they showed increased misbinding. So from this work, we thought that misbinding on this task, moving an item to the remembered location of another item, appears to be associated with hippocampal damage, regardless of the underlying pathology. The other important thing to mention here is this is a short-term memory task. It's not a typical episodic or long-term memory task, which is really the type of task that has been classically associated with the hippocampus. But from our point of view, and many other laboratories, the evidence seems to be that the hippocampus is important for binding information together, regardless of the duration, long or short. So typically in episodic memory tasks, you're having to try and remember something from a past event. Let's say I ask you about breakfast yesterday. You're having to bind together when you had breakfast, what you had, where you had it, who was with you. And it's a similar kind of binding that's occurring here. It's binding different features of your memory together to get a veridical, true response. Okay, so Sophia, with our colleagues in Jena in Germany, has been able to look at data from 48 patients with mild cognitive impairment, 44 patients with Alzheimer's disease, clinically diagnosed, and over 100 people who are healthy elderly controls on this kind of task. There's a lot of data here. I'm not going to go over all of it in detail, but essentially we're looking at 4 different metrics from this task. We're looking at the standard measure of identification accuracy, a measure of absolute error, the localization error in terms of the distance between the true location and the location to which patients dragged the item. We're looking at misbinding rates, what I've just described, and we're also looking at something else, which is guessing. So it's another type of error that we can find on this task. Instead of dragging an item to the remembered location of one of the other items in the array, someone might just drag it to a random location on the screen, and we can quantify that in terms of guessing. And you can see that Alzheimer patients are significantly worse across all these metrics, but they also allow us to pick up patients with mild cognitive impairment who do not currently have a diagnosis of Alzheimer's disease. And together, the 4 metrics together give a very high sensitivity in picking up both MCI and AD individuals. So the question is, can we translate that into something that might work at scale? And this is where we partnered up with Brain+, funded by the EU, to look at whether we can take that task, which works on a large computer screen, and move it to a task which might be a little bit more engaging, a little bit more gamified, and that might be used by lots of people. So the task we use is actually very similar in principle, but there are a couple of differences. The first difference is that instead of using fractals, we decided to pitch this in the form of a game, which is called the Starry Night task. And here, instead of fractals, we're using constellations. We're using constellations because they're complex. They're also difficult also to verbalize in many ways. So again, we might show 1 or 3 constellations. There's a very short delay of either 1 or 4 seconds. And then one of these constellations comes back. In this case, you can see it's this one, together with a distractor constellation. You can already begin to tell this is going to be quite hard. And your job is to touch the right item, so we get identification performance, and then also to drag that identified constellation to the location that you remembered him to be. And you can see it was here in this case in the memory array. And in this instance, there's going to be a little bit of an error between the true location and the location identified by the patient. We've also used an intervening interference task during some of these trials. So instead of just having a delay, what psychologists call an unfilled delay, we now have a filled delay where we get someone to do a completely different type of task and see whether that has an impact on their recall of the constellation and its location. So in this task, during the delay, we can get people to do a task where they're having to find different galaxies which appear at different locations, go and touch those, and then go back to doing this task. So far, and this is where it's been heroic from Eunice's part, we've tested 55 healthy elderly people both on this tablet-based app as well as on the task I showed you earlier with the fractals. So we now have an opportunity to compare performance on both those tasks. So just to give you a sort of cartoon representation of what happens, you might see 3 constellations, they go away, one of them comes back with a distractor, not easy, and your job is to touch the right one and move it to its remembered location. So in this case, the error between the true location and where you pointed, you can see is this much. So we give you feedback on how well you did. And in the interference task, we may show you the 3 constellations, there's a delay, and during that delay, we show you these galaxies that you have to go and touch, and then you have to come back and perform the task, as it were, in terms of identifying the true constellation and moving it to its remembered location. And again, here you can see the error. In the actual app itself, which appears on a tablet, it's far more gamified. Just to give you a feel of that, this is the kind of experience that the participant sees. And in this condition, you will see 3 constellations in the nighttime sky. Job is to move it to its remembered location, and we give you feedback. Here's another trial, 3 constellations. I think the video is stopped there, but you can see that it's not easy about which one to pick here. Let's just move it back. Yeah, and again, you can get the feedback of how well you did. So you get a very good idea of how well you're performing, and we hope that's also engaging for people doing the task. So just to give you a little bit of information on the data here. So here we're plotting identification accuracy, just how well you did in remembering the right item. And for all these conditions, you don't have to worry too much about the details, but here are the 1 item conditions with either a 1 or 4 second delay. And you can see that actually both young controls shown in blue and healthy elderly people shown in red do very well in terms of identification if there's only 1 item to remember. But as soon as you add 2 other items, so now you've got to remember 3 items, and one of them comes back, performance deteriorates quite significantly. And the other interesting thing here is if you do the interference task during the delay, when it comes to 3 items, that's a real big hit in terms of your identification accuracy. Doing an interference task during the delay really impairs your memory for the item that you saw previously. So that's just identification accuracy, the sort of classical measure. But we can also use localization error, and here that's been plotted in terms of pixels of error on the screen, again for 1 item of different delays, for 3 items for different delays, and for 1 and 3 items during the long delays in the interference task. And again, you can see that people do really well for 1 item. As soon as you increase 3 items, you can see there's an increase in localization error. And remember, this is a continuous metric. And here you can see that there's a big difference between elderly controls and young controls in their localization memory. And again, that's clear also when they do the interference task during the delay. Now, what about these misbinding rates? And you remember, misbinding occurs in everybody to some extent, but they become pathologically high in patients who have damage to the hippocampus. And these are normal, healthy people, and we're showing you misbinding rates only for the 3 items because you can only misbind when there's more than 1 item there. And this is for 1 second delay, 4 second delay, so not much difference here, and 4 second delay with the interference task. And again, amplification of misbinding, dragging the right item to the location of one of the other items in the memory array. Similarly, we can look at guessing. That doesn't have such a big difference. There's low rates of guessing comparative to misbinding, but again, doing the telescope interference task has a big impact. And finally, what we can show you is the comparison of the Starry Night task, the app that I've just shown you, versus our sort of lab fractals task done on a large screen. And this is identification accuracy in terms of the fractals task versus Starry Night task, and the misbinding rate, again, in terms of our fractals task against the Starry Night task. And I think these are encouraging results to show that taking a task which was developed for patients in the setting of clinical assessment, clinical research assessment on a large screen to an app on a tablet shows that there is some face validity. We can take those tasks, change the stimuli, and we can still get very strong relationships, both in terms of identification and misbinding. So I think that's been really encouraging from our point of view. And what we're hoping is that then now we'll be able to test at larger scale across people of different ages to see how identification accuracy, localization, misbinding, and guessing change with age. Okay, so I'll stop there and let Ulrich take the reins.
Thank you, Masoud. Ulrich, the floor is now yours.
Let's see if I can make this work. I take this one. Let's see.
Screen now.
You can see my second screen, and now you can see the presentation, right?
Yes, correct. You can start.
Okay. So a pleasure to be invited to participate in this webinar and to kind of introduce sort of the overall perspective. Now we've heard a lot of interesting perspectives on early detection, and also I think Helen really made it evident what the problem is and what we're facing here. So thanks a lot for the input so far. So my presentation is going to be more sort of high level on the project of Alzheimer's detection and prevention, actually also tying this journey of early detection with efforts to prevent or at least reduce the risk of Alzheimer's. So ADDP is all about pre-symptomatic detection and prevention of Alzheimer's, as I will go much more into. We are a number of partners in this project, and you've just heard Masoud from the University of Oxford explain and show some of the stuff that we've achieved to date. Apart from University of Oxford, we're also running trials with Aarhus University and University of Nottingham, and we're collaborating with European Brain Council, Alzheimer Europe, and it's funded by Horizon 2020. And somebody like Alzheimer Europe have been hugely engaged in providing this patient perspective and actually testing it out on people. And then, of course, Brain Plus is involved. So a very nice consortium, all collaborating to basically make detection and prevention of Alzheimer's very early on possible. So, and we have two sister projects as well, sort of on the same mission to detect, prevent, and treat Alzheimer's disease effectively. One is a project called Alzheimer's Shield, which is basically about risk evaluation, looking at risk factors associated with Alzheimer's disease, and then using big data and machine learning to basically group, maybe down to individuals, the profile and match it up with studies showing, you know, what kind of atrophy could we imagine that they have, and what's the risk of a diagnosis like Alzheimer's. We're also working with a project relating to CST for dementia. So that's a specific therapy form which is currently the only evidence-based and reimbursed treatment for improvement of cognition in Alzheimer's patients. So when I continue the talk from here, it's going to be a little bit of a mix, because as we see the solution, it sort of has to be integrated, or that's at least where it comes to kind of full value for the user. So I think why actually pursue this early detection and prevention of Alzheimer's? I think Helen made it pretty clear the reason why, but I'll just add a few more points to it. There was this Lancet Commission back in 2017 that kind of was a group of experts reaching conclusions on the state of dementia prevention, intervention, and care. And they had some conclusions. One of them was that dementia is the greatest global challenge for health and social care in the 21st century. That hasn't changed. It's just been kind of more present. Also, in terms of cases, we're seeing or expecting 66 million people living with dementia by 2030. That rising by 2050 at a very rapid pace. Also, the costs are just tremendous. We're basically spending around 3% of GDP on a European level on Alzheimer's at the moment. Most cases, up around 70% of all AD cases, are never diagnosed. And by the time of diagnosis, the disease is, as today, incurable, as we've also heard so far. So worthwhile reasons why we should try and give it a go at very early detection and prevention of Alzheimer's. I'm just referring back to the same source. So the Lancet Commission actually also had some suggestions as to possible solutions. And one that was highlighted was actually relating to interventions for reducing risk factors. So they said interventions for risk factors, including education, exercise, social engagement, smoking, hearing loss, depression, diabetes, and obesity, might have the potential to delay or prevent a third of dementia cases. So we think that that's already pretty good if we could kind of support that those sort of numbers. Also, the same interventions could actually increase quality of life for those diagnosed with Alzheimer's disease. Then another principle that we've adhered to is that actually the earlier a healthier lifestyle is adopted, the greater the chance of reducing risk and living with a higher quality of life. So there are a lot of unknown aspects around this, but still. So a question from our side was basically, how can a digital tool support early AD risk detection and risk factor interventions? We set out basically with two sorts of objectives relating to this problem. So one was relating to risk detection, where we basically want to provide a scientifically validated digital tool for detection of AD symptoms and all risk factors as early as possible. And the other objective is related to risk reduction. So basically provide a scientifically validated digital tool for cognitive and behavioral interventions to reduce risk of AD. So you see, I mean, one of the reasons why early detection is key in this project is actually because the sooner we can get in, the more likely the behavioral interventions are to kind of change the trajectory. To what extent we can do the screening, how early we can actually catch people, and what it will tell us, and how the outcomes will be. I think that's too early, and that's why we are doing a number of trials to actually investigate these things. And Masoud just kind of showed us some of the numbers that they look very promising so far. But I think as we go with the project, we'll be also communicating whenever we see new results relating to this effort. So some of the key challenges as we see it, one is, of course, to build a screening tool and then scientifically validate that tool actually works and figure out what it actually tells us. I think another sort of really key challenge is that sort of the if it isn't broken, don't fix it mindset, that basically we need to design to engage presumably healthy individuals or identified at risk populations in screening up to 20 years before symptom onset. So it's like, I think it's a challenge getting people to you actually consider stuff and taking actions to change behaviors, you know, maybe up to 20 years ahead of any kind of trouble. We don't go to the doctor often, or we don't go there if we don't have a significant problem. It's sort of the same here. So we need to kind of think about how to really engage people early. We also need to develop an intervention program that's effective and show that with scientific studies, definitely. And then again, the same issue of basically designing to engage people and get them to actually adhere to these interventions to get the outcomes, preferably way before any sort of symptoms onset. So I think there are some issues there that are way beyond sort of the technical ones, but they have to be thought into the technical solutions. Once we have that working, I would say then it's definitely about engaging on a national, regional, and global level, basically to try to get as many people, adult and elderly, in the fight against dementia. And also then work with partner organizations and national healthcare systems to basically screen as many as possible, with main emphasis on AD risk population. So you could say, how does this fit with the Brain Plus mission? I think it's pretty obvious how it fits with some of the other presenters here. So I just want to kind of pinpoint why we really saw a good fit with what we've been doing. So we've been in existence for 8 years, and we have a mission to detect, prevent, and treat cognitive disorders and brain disease in a fairly broad sense, using a specific methodology. So I'll just briefly touch upon that. Basically working with gamified cognitive assessments, using that for a very personalized training plan with mainly two types of interventions. Let me just see if I can get the pointer that Masoud had before. Can I do that? Yeah, I'll just see here. Yeah. Let's see. So mainly two types of interventions. One is neurogames, and the other one is behavioral therapy. So I'll get a little bit more into the details. But basically also applying a lot of aspects of gamification for activating senses and emotions, and basically increase attention and adherence to treatments. Also work with a fairly new kind of multidimensional exercise design. Work a lot with Patrick-centric user interface, continuously kind of testing out, is it working? Is there a gap? Are people kind of not following instructions, or is it too hard in the long run? Also, pretty important, as Masoud said, well, applying machine learning to big data can actually give us a lot of insights into maybe individual cases and what's going on, apart from sort of other populations. And then, of course, scientifically validating all the components in this sort of treatment. So this fits very nice with how we're thinking about early detection and prevention of, let me just see if I can get this out again. Okay, so that's kind of lining up to sort of how we see the steps in the ADDP solution. So if we split it up in kind of two sections, one is about detection and risk profile, and the other one is about prevention. And again, this is also why sort of the early detection is really important for us. Firsthand in the journey, we think it's pretty important to basically motivate people to get started, creating awareness of potential implications of lifestyle aspects or risk factors, and at the same time connecting that with opportunities for actually changing trajectories related to that. So information on brain diseases and the potential for prevention if you engage early. And then basically try to start getting or building motivation to start sort of a journey to change that. That may be a very, very long and difficult journey. Then basically a health risk assessment, or basically just a health assessment, and not talking a lot about risk. That remains to be seen in different sort of usability studies. But what we intend to include there is sort of a risk factor assessment covering a lot of the known risk factors as of today. And also the AD screening test that Masoud just showed, the Starry Night test. And then sort of a game-based cognitive assessment. That will give us a lot of data. A lot of data on the individual and a lot of data on big populations. So we can probably say a lot about the health risk profile, basically give a description of the health profile and also how to interpret that. But again, that needs to be kind of thought through, how to communicate this and how to communicate aspects of risk. It could be either in terms of overall health or in terms of risk level. Basically, what we want to do is to create awareness and sort of a sense of urgency, because that is a key milestone for starting to kind of change perspective and put emphasis on actually taking steps and actions towards a better health. So what we want to show is that basically there's a way forward. We've identified some risk areas. We're not kind of diving in too much about what, any particular percentage or anything like that, but we're saying, well, we've identified some risk areas and here's what you can do in terms of actions to actually reduce the risk. Then basically we use that data to suggest kind of a health risk reduction program, and that's a kind of a training plan generator. It has different components. It has neurogames according to cognitive profile. It has a AD risk reduction program suggested according to the highest risk factor identified on the risk profile. It has monitors on well-being and affective states, so actually also tracking well-being and affective state over time. And how that develops, and then helping the user set objectives for frequency and duration of training. So that's just kind of giving the user an opportunity to affect what's going to happen. Then next step, or final step, you could say, they're going to go onto a daily kind of intervention with cognitive and behavioral sessions. That will include cognitive training with neurogames, and it will include what I will call progressive gamified behavioral change sessions. It will also kind of cast light on progress and overview of how they kind of develop their health or reduce risk. That's sort of the overall journey as we see it. Just to cast a little more light on sort of what the topic here is in terms of very early screening, I would say. So we're definitely not into diagnosis. We could in the future at some point maybe support that, but that's definitely not in the short term and not now. So it may be a good tool for screening as we see it at the moment. Basically, we have the Starry Night gamified AD test that Masoud talked about. We are going to combine that with data from game-based cognitive screening. That is similar games that are intended to stimulate, but at the same time kind of monitor performance on cognitive domains as attention and short-term memory, learning and memory, visual ability and executive functions, and language. And we expect that to kind of be, expanded over time. And for each of these areas, there's a number of subdomains that are actually being stimulated and also monitored. In addition to that, we have this AD risk factor evaluation. So we're now covering actually a number of factors. We have been diving into, for instance, the finger study and the KITE risk evaluation. And I think that's a very interesting starting point and showed kind of the strength of this methodology. The Lancet actually also have added some factors, and a number of studies have later then added other factors, and we have not covered everything, but we've covered a lot of known risk factors in this screening. It's including biological factors such as age, gender, family history, and genetics, lifestyle factors like education, smoking, physical activity, and diet, affective factors such as loneliness, cognitive control, sleep, stress, depression, and anxiety, and physical factors such as hearing loss, BMI, blood sugar, ketones, blood pressure, and cholesterol. So there are a number of factors that we actually get data on, and it's not binary. It's actually quite detailed data on each of these factors, and that hopefully gives us a very good idea in terms of how to kind of tailor the AD risk reduction. We basically only have the two types of intervention that I talked about before, but we have a lot of stuff within each category, you could say. But one type of intervention is this adaptive cognitive training with neurogames, and the other one is gamified behavioral therapy, basically addressing all the risk factors that we just talked about. So the cognitive training is addressing strengthening of cognitive reserve, and the gamified behavioral therapy is addressing changing of lifestyle to reduce risk of factors for AD. And you could say the games to some extent can also do that. And at the same time, we have lifestyle that will actually also address cognitive reserve. So it goes across. Just to give you a last view on how we kind of see the AD risk reduction and how we want to kind of achieve that through what we call progressive gamified behavioral change. We kind of see a model, and we want to support the user along kind of stages of behavioral change, and a lot of you people may know what that's about. But it's basically about having a user that may not be aware of any issue at all. So he's at a stage of pre-contemplation, moving the person, or he can move himself to contemplation, being aware of maybe the urgency and the need for changing behaviors, and envisioning what could that encompass. Moving on to preparation for action and taking steps in terms of actions, changing behaviors. At some point, repeating that, maintaining the behaviors, and there may be a risk of relapse. So we are basically designing around that journey. So in terms of kind of providing risk detection and awareness of kind of the challenges and implications of current behaviors, and providing learning sessions to support the user from basically going from pre-contemplation to contemplation. When we have him over there somewhere, we want to support the user in planning and objective setting, basically supporting preparation for taking actions, and then have specific daily behavioral objectives, monitoring mechanisms, and rewards for supporting these daily actions.
Correct. I'm going to have to ask you to round off, because the webinar is ending in 2 minutes. So,
okay, all right. So basically want to support the user throughout this journey, and hopefully kind of change behaviors significantly over time. So that's it. I basically just want to say thank you for listening, and join us on the journey. So please don't hesitate to contact us, either Kim or I. Yeah, so thanks a lot.
Thanks, Ulrich. And we are nearing the end of the actual webinar, and very, very interesting and good presentations. Unfortunately, we will not have time for the questions, even though there are many, many good and important questions to be answered along this topic. For all of those who do have unanswered questions, I can recommend that you contact the ADDP project, and we will relay any questions you may have to the speakers to them, or if it's directly to the ADDP project, you can also get the contact information. There should be a pop-up on your screen where you can click and get the ADDP website, and also get the contact information there. Again, a very, very warm thanks to our speakers for having shared their knowledge with us today, both the patient perspective, the scientific perspective, and the technical or technological perspective, and some of the challenges that are involved in that. So anybody who is listening today, thank you very much for taking the time to listen to this important topic. We hope to hear from you if this is something that is relevant to you or the work that you're doing. So thank you very much, and I wish you all a very good continued day from here. Bye.